Greeting viewers, FireShark welcomes all its viewers in today's video. Today we will discuss about OSI model. What is OSI model? What are its components, etc. So these are the objectives that we will cover today. The OSI model, its layered architecture and the layers of the OSI model. Let's go in deep. So the OSI model, it was established in 1947 by International Standard Organization (ISO). A network is a combination of hardware and software that sends data from one location to another. The hardware consists of physical equipment that carries signal from one point to another network point. The software consists of instruction sets that make possible the service that we expect from the network. Compare this to a service provided by a computer network. For example, the task of sending an email from one point in the world to another point can be broken into several tasks, each performed by separate software package. Each software package uses the service of another software package. At the lowest layer, a signal or a set of signal is sent to a source computer to a destination computer. So the OSI model is not a protocol, it is a model for understanding and designing a network architecture that is flexible, robust and interoperable. The purpose of OSI model is to show how to facilitate the communication between different systems without requiring change to the logic of underlying hardware and software. Layered architecture of OSI model. The OSI model is composed of 7 ordered layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. The layers are involved when the message is sent from device A to device B. As the message travels from A to B, it may pass through many intermediate nodes. These intermediate nodes involve only the first 3 layers of OSI model. In the developing of model, the designer distilled the process of transmitting data to its most fundamental elements. They identified which networking functions had related users and collected those functions into discrete groups that became a layer. Each layer defines a family or of function distinct from those of other layers. P2P process. In the figure we can see device A sends a stream of bits to device B through intermediate nodes. At higher layers, however, communication must move down through the layer on device A, other to device B, and then back up through these layers. Each layer in the sending device adds its own information to the message it receives from the layer just above it and passes the whole package to layer just below it. At the layer 1, the entire package is converted to form that can be transmitted to the receiving device. At the receiving machine, the message is unwrapped layer by layer with each process receiving and removing the data meant for it. For example, layer 2 removes the data meant for it, then passes the rest to the layer 3. Layer 3 then removes the data meant for it and then passes the rest to layer 4 and so on. Interface between layers. The passing of data and network information down through the layers of sending device and back up through the layers of the receiving device is made possible by interface between each pair of adjacent layers. Each interface defines the information and receives a network layer must provide for the layer above it. Well-defined interface and layer function provide modularity to the network. As long as layer provides the expected service to the layer above it, it specifies implementation of its function can be modified or replaced through requiring changes to surrounding layers. Organization of the layers. Each layer at the sending site uses a service of layer immediately below it. The sender at the higher layer uses the service of middle layer. The middle layer uses the service of lower layer. The lower layer uses the service of the carrier. The TCP/IP protocol suite became the dominant commercial architecture because it was used in and tested extensively in the Internet. The OSI model was never fully implemented. So, as we discuss briefly the OSI model, then we will concentrate on TCP/IP protocol suites. So these are the layers of in the OSI model. The OSI model is a layered framework for the design of network system that allows communication between all types of network system. It consists of 7 separate but related layers, each of which define a part of a process of moving information across the network. There are 7 layers in OSI model. First, application layer. Second, presentation layer. Third, session layer. Fourth, transport layer. Fifth, network layer. Sixth, data link layer. Seventh, physical layer. It totally depends on you that how you take these layers. You can also write application layer on top, but you can't merge the layers. You have to follow the order. You can also write in this way: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. But you can't merge the layers in between. You have to follow the order. So that's it from today's video. We have briefly discussed what is OSI model. So we will see the layers in next video. We will briefly discuss each and every layer. Thank you for watching.